Hello, everybody. So, I hope you are doing well. So, this is my lecture for week 14, session 2. In this presentation, I will go over a simple method for cost estimation of engineering project. And more specifically, I will go over the cost estimation, a simple method for cost estimation of your thermal system design project. Keep in your mind that this is a very simple method as to just get some idea about the total cost and also the net cost. If you need uh, to get accurate actual value, so you need to just uh, you know um, uh, find the other methods, I mean the accurate methods, to get some idea about the cost estimations. This is a very straightforward, simple, convenient method to get some idea about the cost estimation. So here you can see the different actually elements of cost estimation. So generally speaking, we have two types of actually cost: capital cost and operating cost. The capital cost, actually, they are fixed. We just pay in the beginning of the project. So actually capital costs include equipment cost, land and construction, piping, and engineering costs. And so for the equipment, normally you need to consider the equipment cost plus installation. And also for the piping, you need to consider the pipe cost and installation. For the operating cost, you can actually consider utility cost, raw materials and chemical cost, labor cost, maintenance, and miscellaneous cost. In some cases, you may add, some other elements, for the operating cost. For example, waste treatment, wastewater treatment, element. So I just consider, these, five elements. Keep in your mind that for the labor cost, you need to actually consider operating costs, operating labor costs, non-operating labor costs, administration, and supplies. Let's start from the capital cost and from the first element, which is the equipment cost. For the equipment cost, you need to use the um, results that you actually obtain in the report 2. In report 2, you design the heat exchangers, and then in for the third report, you need to actually design the pump. You need to design the turbine generator, and if you have any solar cell, you need to design the solar cell. If you have any pond, you need to design the pond. So for the equipment cost, normally we actually may have some equipment with the actually available detailed design. For example, for the heat exchanger, you have all detailed, for the heat exchanger, you have the, for example, if you have a shell and tube heat exchanger, the number of tubes, the tube size, the number of passes, the actually baffle sizing, baffle spacing, you actually know the shell actually diameter. So you have all information, the materials. So what you can do, you can calculate the material cost by having all this information, and then you can add manufacturing costs. You can consider between 20 to 100% of material costs as a manufacturing cost, and then the combination of these two elements will be the equipment cost actually for the heat exchangers. For some other equipment, for example, for turbine, for generator, for pumps, you just have, the capacity. For example, the, let's say, for example, the power for the, turbine. So in these cases, what you can do, you can check the suppliers, catalog, and then from actually those suppliers catalog, you can find, the cost for, that equipment. Keep in your mind that in some cases you can't find, you are not able to find, the exact value for that, for example, power or that capacity. In these cases, if you are not able to find, for example, the exact value, for example, you're looking for a turbine with 70 kilowatt, for example, power, and then you actually in the catalog you have a turbine with 70, for example, kilowatt and 80 or 90 kilowatt. So you don't have exact value for the 75. In these cases, you can use this equation to find, the cost for equipment with unknown, actually, cost. So what you can do, you can write the cost for equipment A equals the cost for equipment B. This is actually known. You can find, this cost, for example, from the, suppliers, catalog times the capacity of equipment A over capacity of equipment B 2.6. So from this equation, you can find, the equipment cost for uh, equipment that actually, you don't have any information. I mean, you don't have the exact capacity in the, catalog. And then you need to actually consider 2 to 10% of the equipment cost for the installation cost. And then the combination of actually the equipment cost plus installation cost will be, the total cost for equipment. So the next item is construction cost. For the land and construction, so you need to actually first calculate the construction cost of shell. So for the shell, what you need to do, you actually need to prepare the site layout. By having the site layout, you can calculate, the total area required, for the equipment and also for the piping. So you have the equipment dimensions, you have the piping actually sizes, piping lengths, for example, between the equipment, and then you can prepare the site layout. And then based on the site layout, you can calculate, the area required, for the equipment and also, for the piping. So keep in your mind that you need to consider enough space, between, the equipment. And so when you calculate this area, you can use, the North American Industrial Location Index. I share, this file on the Blackboard. So you can use actually, this file here, based on, the site location. So, for example, if you, want to just make, for example, this, unit in Los Angeles, so you need to use, information for the Los Angeles. So you have, several options here. So then when you actually select, the site location, you can calculate the, construction cost for shell, in this actually column. So this is actually the values, per square feet. So if you have the total square feet, you can actually, calculate the total, cost for the, shell. For the land, you need to calculate the total cost for the land. For the land, what you need to do, you need to consider the total actually area required for the land. So you need to add, the area for the, equipment plus, area for required for the office, for the parking. If you have the solar cells, you need to actually add area required for the solar cell. If you have pond, you need to consider area for the pond. If you have any other, equipment, you need to just add the area for the pond, and then you can again, after you calculate the total land, you can again use, this table, this column actually, this one, to calculate, the total actually cost for the land. So this is the dollars, per acre. So yeah, by using this table, you can calculate the total area, the total cost for land and construction. So then you need to calculate the pipe cost for the, piping and, engineering. For the pipe cost, you have actually information for the pipes. You already designed, the pipe, so you have the pipe length, you have the pipe actually diameter, the materials, so you can calculate, the total cost, for the pipes. So if you have two loops, you have, in most cases, you have two loops, so you need to calculate, the total cost, for the piping. And then the next step, you need to calculate the cost for the valves, elbows, joints, and these actually elements, and then add these two elements to calculate the total you know um, pipe actually cost. Then for the installation actually cost for the pipes, you should assume something between 10 to 40% of the pipe cost as the installation. And then the last is the actually item in the capital cost is engineering. This is your actually cost. This is your salary. So you need to just check, Google it to just get some idea about, the engineering costs, and then add the engineering costs, for the actually design this, unit. Then you can calculate the total capital cost. The total capital cost is, a combination of all these elements: equipment, land, construction, piping, and engineering. Now, keep in your mind that this capital cost is a fixed cost. So you just paid, in the beginning of the, project. Then you need to calculate the capital depreciation. What is the capital depreciation? It's a fraction of the investment of the capital cost to each unit of the product that you made, in actually your plan. So normally we use D to show the depreciation. The unit for the depreciation is dollar per actually unit of product. In this project, in most cases, the unit of product is kilowatt hour. So to calculate the D in dollars per kilowatt hour, you should actually divide the capital cost, the total capital cost. You already determined the total capital cost. Divide by the plant life. So the plant life is in year. Normally, in most cases, we assume 8 to 10 years, for the plant life. You can assume, that 10 years, for actually plant life, in this case. And then you need to multiply it by the annual production capacity, which is kilowatt hour per year, in your project. So planned life is 10 years, just consider this is the 10 years. And then for the annual production capacity, we use the kilowatt hour. So the kilowatt hour is a unit of energy equals to 3,600 kilojoules. So to calculate the kilowatt hour per year, so you need to multiply the power of your unit by, 3,600 multiplied by 24 multiplied by 365. So first you calculate it, you convert it to the hour, then you just convert it to the year. Correct. So this is the annual production capacity in kilowatt per year. So then you will be able to calculate the D, the capital depreciation. Keep this D, and then we will use this D at the end of this project to calculate the net, cost. So D equals the capital cost over 10 times, the annual production capacity, which is, you can calculate it, from this, equation. So I think for one project for the RO, plant, actually the production capacity is based on the purified water capacity. I think it's something around 10 cubic meter per hour. So for that case, you need to calculate the D will be in dollars, per actually cubic meter. So to calculate, the depreciation for that RO system, you need to divide the capital cost by 10 times annual production capacity. In that case, the annual production capacity is 10, for example, cubic meter per hour. You need to just calculate the production capacity in a year. You need to multiply by 24 and then 300, 65, days. So then you will be able to calculate the D, the capital depreciation. So this is, actually capital cost part. For the annual operating cost, so you need to actually first calculate the power, the utility. Utility includes power and water. So for the power, you have, you have information, for the pumps, for the, other equipments, so you can calculate, the total power, and then you can calculate, the annual, power cost. So this is one method. The other method, because in most cases you are actually generating, electricity. So what you can do, you can actually subtract this power required, for the equipment from the, total, capacity. For example, if you are asked to design a, for example, or a solar cell, for example, power plant, with, for example, 50 kilowatt, and then you need, for example, 1 kilowatt for the, pumps and for the other, equipment. So you can assume that the net actually power generation for your system is 49 kilowatts. So 50 minus 1. This is one method. The other method, you can actually calculate, the annual cost for this power. So you can use one of these two methods to calculate, the power. So if you need water, for example, for the RO system, you need to have actually, for example, to use the tap water. So you can, you have the capacity, and then you can calculate, the, cost of, water. And then the combination of these two elements would be the utility. Raw materials. For the raw materials, you need to calculate, cost of working fluid. To calculate the cost of working fluid, you should calculate the volume of, working fluid required for your system. To calculate this volume, you can calculate the volume of the cycle. You have the pipes, you have the diameters, you have the lengths. You can calculate, actually working fluid required, to just fill, these, pipes. Also, you have information for the heat exchanger. You have the pipe size. You can calculate, the working fluid required to fill, that, actually pipes, as well. Keep in your mind that the working fluid is in liquid format in actually some parts of the cycle, and it's in vapor, format in some other, part of the cycle. So if you want to calculate the mass of the total mass of the working fluid, you should use two different, density, for the liquid and for the vapor, to calculate, the total mass of, working fluid. So when you calculate the total volume of working fluid, or the total, mass of working fluid, you can multiply it by the unit price of the working fluid to calculate the raw material. In some project, you need to actually use oil. So by using the same method, you can find, the actually annual cost, for the oil. So you may need to use chemicals for the heat exchanger cleaning. You can assume, cleaning every 3 months, every 6 months, for the heat exchangers. And then, you can calculate, the amounts of chemical required, and then also, the cost required, for the chemicals. And then the combination of these elements will be, the raw materials. The next actually item is the labor. Labor includes, four different items. The first item is, operating labor. For the operating labor, to calculate the annual cost of the operating labor, you can assume that, there are 2 to 6 operating personnel per shift, and then you can consider 4 shift, and then you can consider, 75K per year for each, personnel, and then you can calculate the total annual cost of operating labor. Also, you need to consider the non-operating labor cost. Normally, we can assume, the 60% of the, annual cost of the operating cost as the, annual cost of non-operating labor. So just 60% of these costs. Also, you need to consider the administration. Administration is something around 90% of the, operating labor cost. And then the last one is supplies. You may need to consider, some other items such as, office items, protective equipment for the, personal, and then you can actually consider 30% of the operating labor cost as the annual cost of supplies. And then the combination of these four items will be the labor cost. And then for the maintenance and for miscellaneous costs, for the maintenance you can assume that actually 0.2% to 0.6%, sorry, 2% to 6%, my bad, of the capital cost is capital cost divided by 10 is the annual cost of the maintenance, and then for miscellaneous costs such as taxes, insurance, and these things, you can assume 1% to 2% of the capital cost divided by 10. And so now you are able to calculate the annual operating cost. If you add all these elements, raw materials, utility, labor, maintenance, and miscellaneous, you will be able to calculate the annual operating cost. Now you need to just calculate the operating cost per kilowatt hour. So if you divide the annual operating cost, you already determine, in this section by the annual production capacity, which is kilowatt per year, or which is cubic meter per year, for the RO system, you will be able to calculate the operating cost. And let's use B, to show the operating cost per kilowatt. Now, you can calculate the net cost. What is the net cost? Net cost is the combination of the B, the operating cost per unit product, plus the depreciation. So the combination of these two is the net cost. Now you have the net actually cost for your product. What you need to do, you need to actually compare this net cost with the available option in the market. For example, if you generate power, you can check your electricity cost with the, for example, available electricity, industrial electricity, for the industrial purposes, in the market. And then you should actually analyze your cost. Does it make sense, this value that you determine, if it's much higher than the values in the market? Do you have any explanation for this difference? What happened? So you can calculate the net cost, and then you can compare the net cost with the market. Thank you so much, guys, and have a great day.